Okay, today we're going to be doing some animating in Solidworks. And our demo that we're going to be doing is an ornithopter. An ornithopter is basically a flying machine that looks a lot like a bird flapping its wings. And here's what we're going to be working on today. So you can't see it, but there's a DC motor in the back here driving some gears. There's a shaft that goes from the back to the front, drives this small gear, which drives the large gear, which drives the other gear. Both of those gears cause these wings to flap as they rotate around. And then there's a tail rotor at the back side, which is just a servo that helps it steer. So we're going to be working on animating this today, and you'll notice that this looks like a rendered image. It's a really nice looking image, and we'll make sure that we do both the slower rendered animation and the faster rough draft quality animation. Okay, so we're going to start an assembly, and you should have the files already downloaded. There's an Ornithopter file for you to download. I'm going to bring in the body first. So the body is Ornibody 2. Okay, we'll just drop that in there somewhere. And there's the body. I have already given this some material. I think I gave it a carbon fiber material. If you want, you can change that so it's a little bit easier to see. I don't remember what I chose the first time. Yeah, I gave it some kind of carbon fiber. Let's just give it to make it a little bit easier to see, let's give it some glass fibers. There. Now it's all gray. It's a little bit easier to see this time. Okay. We'll save that. Alright, so there's our body. First thing I'm going to do is I'm going to assemble the motor, and the motor is going to be mounted on these three holes. So let's go grab our motor, and the motor is called the motor BLDC, brushless DC motor. Okay, so it'll sit in there. I'm going to assemble this in what I think is the easiest way. I'm going to mate the holes together. So I'll choose this top hole, and then I'll choose the top hole on the motor. That should bring those together. And then I'll choose one more hole. I'll choose this bottom right hole. And now those should be together. And now the last thing we have to do is just mate this end to this end. And this should be good to go. So there's our three constraints on the motor. Looks like it's in about the right position. Okay. Next, I'm going to go grab the motor that attaches to the end of that shaft. Okay, or the gear that attaches to that shaft. So that will be the spur gear small. Okay, and I'm just going to kind of drop it in. It doesn't really matter. Oh, it went over there for some reason. It doesn't really matter. We're going to put our mates on, and that will solve everything. So I'll mate those two cylindrical surfaces, the inside of the gear and the outside of the motor. And then to finish that off, I'm going to mate this side of the gear to this side of that body piece. Okay, close enough. That's good enough for what we need today. Now, that should still, if I close out our mating, that should still allow this to rotate. Perfect, that's what we need. Okay, let's go get the next motor that attaches to this, and the next gear. The next gear that attaches is the spur gear medium. Okay, so that's going to go over here. Okay, we're going to mate the inside of that gear, and then we're going to mate the inside of that hole. Okay, and it chose to go way over there for some reason. We're going to mate this wall and this side of the gear. Okay, that looks good. Now, that should still be free to rotate. This one's still free to rotate. Perfect. Now, the issue is they're not rotating together, right? So ideally, if this gear turns, it's meshed with this gear, we'd want it to turn there too. So there is a way to do that in SolidWorks. And we're going to need to be able to do that if we want to turn this motor and have the whole thing flap its wings. So those are more advanced mate. They're not the the standard mates, they're in the mechanical mates. So we're going to go down here to mechanical mates, and then you'll see that there are gears. So that is perfect for us. So what we're going to do is you have to select the inside of your gear. If I can figure it out. That looks like the shaft. So I'm going to right click. I'm going to do select other. Select other should allow me to see some of these other options. So if I go down here, maybe it's easier to stretch this out. I want not the edge, I want the gear. I want the face, the inner face of that gear. So there's the first thing that I want to grab. Okay. Second thing I want to mate to is the inner face of that gear. Perfect. Now the other thing I have to tell this mate is what is our gear ratio, so that it knows how fast to turn these. So gear ratios are pretty simple if you just go by number of teeth on the gear. So I pre-counted these. There are 15 teeth on the small gear, 20 teeth on the medium gear. So I'm just going to go, my ratio is 15 to 20. Now it changes it to 15 inches and 20 inches. I don't really know why. Doesn't really matter because it doesn't affect us at all. So let's try that. Okay, as we rotate this gear now, we click on it and rotate it, it should have it the same gear ratio and it should turn appropriately. So let's find out if it does. Alright, so what I'm checking for is to make sure that all of those teeth are mating properly, meshing properly, and it looks like they are. So that looks pretty good to me. I think I will let that go. Looks perfectly fine to me. Okay, so let's move over to the other side. Now what happens is there's a shaft that connects this gear to another medium-sized shaft over here on this side. So let's put that other gear on first, and then I think it'll be a little bit simpler to see. So that is spur gear medium 2, and we're going to put that right there. So let's go back and mate that again. So the inside of that gear and the inside of this wall. Okay, and it put it way over there for some reason, but that's fine. We're going to drag this over a little ways. Alright, perfect. Now I want to mate this wall to this side of the gear. Perfect. Okay, so now in an ideal world, if I spin this gear up here, this one's still spinning, and it would somehow automatically know that that gear over here should spin too. It does not. So we're going to have to fix that on our own, and the way that we're going to do that is through a shaft. So we're going to browse and we're going to get another part. This one is called connecting rod. Okay, so we're going to put the connecting rod in there. Similar mating style to what we've been doing, so we will mate through there. Good, and we can just kind of push that closer to be in place. And then I'm going to mate this end of the connecting rod to that side of the gear. That looks good. And if I go around to the other side, it should also match. And it does, so that's perfect. Alright, so now if I turn this gear, this side's still working, that side's still not working. So we still have to fix that. So there's probably quite a few different ways that you can do this. The way that I'm going to do it is I'm going to lock a plane from this gear to a plane on this shaft. Then I'm going to come over here to this side and I'm going to lock that same plane from this shaft to a plane on this shaft. That way, when a plane is rotating on this gear, this first medium gear that we installed, it's going to force the shaft to rotate. If the shaft has been forced to rotate, this gear is also going to be forced to rotate. So that should get our rotation from one side of the wall to the other. So let's figure out how we're going to do this. So I'm going to click on this one first. This is our first medium gear. And what I want to do is I want to find through some of these planes. I'm going to look through these planes and see which one of them rotates along with the gear. So it's plane 1. We might have to zoom out to see these planes. Plane 1 would work, because as that gear rotates, that plane is also going to rotate around. Plane 2 would work just fine. Plane 3 would not, because as this rotates, the plane is not going to change at all. So plane 1 or plane 2, either one of those would work. Okay, let's close that. So we're just going to have to remember, either use plane 1 or plane 2 on the gear. And now on our connecting rod, let's open that up and see what kind of planes we have. And maybe we'll look at it from this side. Front plane, that would work, because that rotates. Top plane does not work, and right plane would rotate. So let's just say we're going to use front, and on this spur gear, we're going to use plane 1. So plane 1 and front are the ones that we're going to mate. Okay, well let's do that then. So we're going to mate, and now it's a little tricky here. We have to open this window. We have to open this tree here, and now we're going to see this first spur gear. We said we are going to take plane 1. Okay, so that showed up over here in this blue box. Now we're going to close that tree, and we're going to open our connecting rod, and we said we were going to take front. Okay, so good. That plane rotated to match the plane from the spur gear. So we're in good shape there. It looks like those are locked. And let's close that mate, and let's just try it out and make sure that we're doing this properly. Okay, so now we should be able to see this little tiny keyway. We should be able to see that rotate along with the gear now. Okay, good. So that looks like it's rotating just fine. So now if it's rotating on that side, that means it has to be rotating on this side. But our gear still wasn't turning, right? Because we haven't locked the plane from this connecting rod to this gear yet. So same thing, we should be able to do the exact same thing here. Let's open up this thing. Plane 1 would work and plane 2 would work. And then same thing, connecting rod, we'll just use the front again. So let's go back and mate these again. So connecting rod, we're in that tree right now, so let's choose the front plane for that. And now let's close that tree, and let's open up our spur gear medium 2, and we can choose either 1 or 2. I'll pick number 1, doesn't matter. Okay, we can close that mate off, and we're good to go there. So now finally, if I come over here and I turn this gear, everything's turning as it should be over here on this side. And if I rotate just a little bit, we should be able to see both sides. So perfect, everything is rotating just fine now. Alright, so there's part of our problem solved. That's how you properly assemble a file so that when you go to do the animation, it should work out perfectly. Okay, so let's add 2 large gears on here now. So I'm going to go back and insert. I'm going to find my spur gear large. Okay, and Solidworks is attempting to help me locate that, but it's not doing a very good job. Perfect, we'll leave it there, that's fine. Okay, same as before, we're going to choose the insides of these holes. Whoops, close that one. I'm going to drag this thing over a little ways. And you don't have to do this part. Well, we'll do that on the next one. Let's drag this a little bit farther, there we go. So now I'm going to mate that from this wall to this side of the gear. That's perfect. Okay. We'll do that over here on this side too, on that location. So let's go get one more large gear. Okay, I will mate this center to this center. And we will mate this wall to this side of the gear. That should bring that into play. Okay, now this is not entirely obvious, but for this Ornithopter design, your gears have to be facing the opposite direction. So my little hole, which is going to be attached to another connecting rod, and this little hole, they have to be on opposite sides. So if one is on the left, the other one should be on the right. Okay, so it should look like that. And now let's do a couple other things. Let's check how these gears are meshing. Okay, that's not a good mesh. That wouldn't really work in the real world. This one also not very good. So let's just turn this one ever so slightly. Now that should work. And same here. Turn that one a little bit. I think that's okay because I think this one was actually slightly above the horizontal plane and this one's now slightly below. I think we're fine. Okay, so perfect. That should turn our ornithopter properly now. Okay, let's close those up. So let's go test it. Everything's working over here yet. I don't know if we can see this anymore. Let's zoom in. Okay, our bottom gear's working, but we did not do our mates with our gears over here on this side yet. So let's do that real quick. Alright, mate. And we're going to go off of the standard mates and we're going to go onto the mechanical mates and we're going to choose a gear. So we're going to choose the inside of this wall again, and it might be really difficult. There we go. So there's the inside of that gear, and now we'll choose the inside of this gear as our second face. Okay, now I pre-counted the number of teeth on each of these. This smaller medium 2 gear has 20 teeth. The large gear has 50 teeth. So I'm going to say that our gear ratio is 20, and it's going to change that to inches again, 20 to 50. Okay, let's try that. Let's see if that's working. So if I drag this one, well, it looks like it's kind of working, huh? But not quite, because something went wrong with the direction. So let's go see what happened there. The easiest way, if you make a mistake on a mate, the easiest way is just to open up in your tree, find your gear mate, and edit that feature. So I don't know if I clicked this or if it automatically checked it or something, but we have this issue. This reverse has been pushed. So let's try that one more time. There we go. That looks better this time. Looks like the teeth are meshing properly, so we're good to go there. Okay, now we have, we better make sure that our holes are lined up here again. Let's rotate this one around to the left side, this one's still on the right side, and then let's make sure our teeth are meshing. They not quite. We'll move that one just slightly. Make that mesh a little bit better. Perfect. Okay, now let's do one more gear mate. Okay, and this time we'll take this one, and we'll take this one, and you see that the ratio that they gave you by default is 0.2 to 0.2. It's fine. If we put 50 to 50 in there, if we put 2 to 2 in there, it doesn't really matter. The gear ratio was 1 to 1. These are the same gears, so they should be rotating at the same speed. So that's fine. Doesn't really matter what we put in there as long as it's the same thing. Alright, let's try turning this and see if we get motion from everywhere. Okay, perfect. We do. Now that looks good, and let's double check and make sure this is still working over here. So if we drive it all the way from the very first gear, we should be getting output on the large gears, and we are. So that's great. Looks like we've got everything working so far. Next thing to do is to add the wings. So let's go add some wings. We're going to install some new components, and the wings are called, I think they're just called wings. Okay, so I don't know how we'll line that up. That didn't work out very well. Let's try to drag it out a little bit. There we go. Okay, so we're going to mate the inside of this hole and the inside of this hole. I'm not sure what it did there. That certainly didn't work. Let's try that one more time. So let's, oh, it grabbed a tangent for some reason. So let's just delete that one. Start that one from scratch. There we go. So we'll take the mate, the inside of that hole, and the inside of this one. And those should be concentric this time. That looks good. Now do we have our wing on the right direction? That looks like it's backwards. So to reverse that, we're just going to change this mate alignment. There we go. That looks good. Now we just need to move it into its position. So I'm going to mate this front face and the inside of this face here. That looks good. Okay, that looks fine. Now if I grab this, I still should be able to rotate the wing, which I can, so that works. As long as we're putting wings on, let's go ahead and put the other wing on. Just drop it over there somewhere. Okay, and we'll mate doing the same method as before. And it looks like by default it also put that one on backwards, so let's change that mate alignment. That looks better. We can kind of move that closer to where it should go, so it's easier to understand what we're doing. That face gets mated to this face. Looks perfect. Okay, that looks great, except for the wings being a little bit wonky. There we go. Perfect. Alright, so now we need to add some connecting rods between these small holes on the large gears and this hole here. So as this thing goes around, it's going to drive this wing up and down. Alright, well let's install our two links. That is called the link crank. Okay, looks something like that. And you know what? As long as we're doing this, let's add one more link crank for the other side. Just drop it over there for now. Okay, we'll mate up our cylinders. There we go. And then as I bring this one in and I mate this one, it should move the wing for us. Oh, did I make a mistake? There we go. Forgot to push the green check mark. There we go. Perfect. So now it adjusted the entire assembly for us to make sure that those could line up properly. Okay, so that looks good. Let's go over here and do the same thing. And one more up here. Okay, perfect. Now the wings are linked together. They should be moving properly. The only thing we haven't done is we've got these kind of going through our gears. That's a little bit strange. So let's kind of drag them out a little bit. There we go. Now let's mate the front side of that gear to the back side of this connecting rod. There we go. That's perfect. And let's do the same thing over here. Front of this gear to the back of this connecting rod. Perfect. Alright, that looks great. And let's just give it one quick test here. If I turn this very first gear, will it rotate the wings and move the wings? And it is. So that's perfect. Alright, last thing, we've got the tail. So the tail is driven by a servo motor, and that servo motor is just this kiso. And I think you'll figure out how this gets mated in there pretty quick. So it's just a rectangle, real simple. So we'll put the bottom of this servo onto the bottom of that box. We will put this face of the servo on this side of the box. And then to put it all the way in, let's just choose the back of these mounting screws to the front of this box. That looks perfect. There we go. Alright, servo is installed. So let's go ahead and get our tail. And that's literally just called tail. And it looks something like that. Oop, wrong button. And we'll mate this. Same way we've been mating the rest of this stuff. Okay, but that looks like it's on the wrong direction, so we're going to flip that one around. There we go. And then last mate we need to do, we're going to mate that face of the motor to this side of the tail. Perfect. Alright, so there it goes. So to run this Ornithopter, we've got a DC motor that's just going to be turning at a constant rate to flap those wings. And then back here, we've got a servo that can do what servos do. They can rotate to a specific angle to help steer the machine. Okay, so that's good. We're all done with that. So now we're ready to get started with the animation portion. And before we move there, I've already done this for you ahead of time, but I just wanted to point this out. We're going to be doing some photo rendering, and for photo rendering, you really want to have a material for each part chosen. So if we look at any of these parts, like if I open up link crank, this is that small link that connects the gear to the wings. We want to make sure that there's an actual material. So for this one, I've chosen an aluminum link, aluminum 6061 alloy. So when we render it, it'll sort of look like aluminum. It won't just be a gray color. It'll have that sort of look and texture to it. We made this one fiberglass at the beginning of the video. I think I made all of these gears aluminum, and I think everything else has some kind of, these are plastic, a nylon maybe, I can't remember what it is, but they all have a certain material specified for them so that they'll get the texture correct for the photo rendering. Okay, so let's go ahead and start our animation. So we're going to go up here to Solidworks add-in, and we're going to be doing some motion. So if we turn on the motion, and we can go down here to motion study number 1. Okay, and it looks like this is minimized, so to make that bigger, I'm going to go over here to this triangle. I'm going to expand that. And so the majority of what we want to show is all driven by this one DC motor back here. So I'm going to put a motor onto this gear. So that's going to be what our task is, our first task. So let's go look at some of these buttons that we have. These are the buttons up here that we have available to us. And if we start here with the physics portion, so here's a motor, so that's what we're going to use. You can add springs between components. You can add dampers. You can have a specific force acting on a component. A contact, so that would be as if a cam, for instance. Gravity, good one. And then you can do some plotting. And then there's some more advanced properties, which we'll be going over when we get ready to actually render the animation. Okay, so we want a motor. So we basically want to say that we have a motor that's attached to this gear, right? Because we want this thing, ultimately we want that thing to turn. We don't really care if this motor shaft turns or not, we really just care if this thing turns. So if we go over here, this is our options for the motor. We can have a rotary motor or a linear motor, which is essentially just an actuator. Okay, first thing they ask for is the motor location. Alright, so what they mean is, where is this thing attached? So we're going to do select other, and we're going to try to get the inside of this gear again. So we're going to look through spur gear. If we look for spur gear small, it's not the teeth, it's not that, none of those. There we go, that's the one we want. The interior of that spur gear again. Okay, so you'll see a little curved arrow appear there. So that's what we want. And you can change the direction of that. For our purposes, I don't know if you can see it. Yeah, there we go. So the motor can go either direction. Not a big deal for us. And then it wants to know, the last box down here, it wants to know what is it moving relative to. So let's say it's moving relative to this frame. That makes sense, right? Okay, and then we can do all kinds of things with the actual speed. It can be constant, we can go for a certain distance, it can oscillate, we can do segments, data points, it can be a servo. We can load a function from a file. I mean, it's extremely powerful what we can do here. For our purposes, we can just use a constant speed today. And sure, 100 RPMs works for me. For what we're doing, it doesn't really matter how fast we're going today. Okay, so that's it. We can install that motor. We push the green check mark, and now we've got a motor. Now down here, it's trying to tell us some things. It's telling us that we've got this motor acting for 5 seconds. And this black line at top tells us that our entire animation is going to last for 5 seconds. That's good enough for me for right now. That'll be just fine. You know what? I'm really excited to see what this looks like. So let's just go ahead, get a good view here. something like that. And let's push the animate button and just see what happens. So we're going to push this calculate button first. That's going to calculate all the motion as it goes through. So let's do that and watch what happens. Okay, pretty neat. We see that it's turning that back motor, and if we turn around this direction we can see what goes on back there. Oh, there we go. So we can see that it's turning. That's awesome. That's fun. Let's go back to this kind of front view again. Zoom in a little bit. There we go. So I really like that. That's pretty neat. Well, what else can we do? Maybe we can try something else. Let's try some options. So, what did you think of this video? A little bit jerky to me. I don't know if that'll come across on the YouTube video or not, but on my screen the motion looks just a little bit jerky. So there's a way we can improve that. That's especially important when we're going to start doing our photo rendering. We want that thing to look really nice. For our rough draft quality, maybe it doesn't matter so much. As long as we can tell what's going on, that's probably good enough. So let's increase the quality. So that's where we're going to go down here to this motion study properties button, and we're going to increase this. So the animation currently is showing 8 frames per second. We would probably prefer to see that in 30. If we go down here, close the animation, let's go to basic motion. Same thing here. So it looks like it's calculating the motion at 16 frames per second. We want it to be 30. And if you really want to get a little bit better, you can increase your geometric accuracy and your 3D contacts. So that's where like the gear teeth are meshing. So if there's a little bit of backlash, if you were showing high contact resolution, you'd maybe be able to tell that backlash, depending on the rest of your settings, I guess, too. And then motion analysis, let's just increase that to 32, and let's, I don't know, put this somewhere in the middle. And that'll be fine. We'll leave the rest as default for now. Okay, so let's try saving our first animation. So we're going to go right here. There's a button called Save Animation. And I always choose MP4s. That's my preferred style. So I'm going to call this one Test 1. And notice the resolution and the frame output that they're giving us by default. So they're giving us 1920 by 727 as our pixel sizes, which is a little strange. We probably want something a little bit more normal. So let's uncheck this. Let's do 1920 by 1080. That's regular HD quality. And you'll see that back here that the box changed sizes. And that's to reflect our new ratio that we're using. Let's go back to fixed now. Yeah, that's perfect. So that's great. Over here on this side, it's asking us how many frames do we want to output per second. And we just had it do all of the math for 30. So let's go have it do 30. And do we want to do the entire animation? Yeah. Otherwise you can do like 0 to 2 seconds or something like that. But let's have it do the whole thing. Okay. And the last thing to check up here is currently our renderer is the Solidworks screen. In a second we're going to change that. Okay, so let's push the save button. Alright, and let's go look and see what our video actually looked like. So off screen I'm opening up that animation. Here it is. Oh, I did something. I made a mistake. I didn't have it recalculate the calculations after we made all of our changes in our properties. So let's have it recalculate. That is this button over here. So calculate all of those one more time. It looks a little jerky right now. I don't think that's real though. If we push play, yeah, that looks pretty good. Looks much better than the last time we saw it. So let that be a lesson. If you're not getting increases in your quality when you update those, or if you get a still frame like I got in my first attempt, that means you forgot to recalculate. So go over here and push the recalculate button and then save your animation. So let's save that one more time. I'm going to call that test 1 one more time. 1920 by 1080, and frames per second is 30. And I want to change that to an MP4. And we'll just delete that first one. There we go. Alright, let's save that one more time. Yeah, this looks a little bit better. It's taking a little bit longer to complete that save because it's going through and it's doing some calculations to make that animation again. So currently we're almost through 2 seconds of rendering. I don't know how many seconds that's been, but a 5-second rendering like this on my computer probably takes 30 to 60 seconds. And consider this rough draft quality. In a second we're going to change this and we're going to put it into the photorealistic quality, and that might take your computer 20 to 30 to 40 minutes to render 5 seconds of animation. Okay, looks like it has, oh there we go, it has finished. And I'm going to open it up off screen. There we go. Here is our animation. So that looks great. 5 seconds. Let me put that on repeat so you can see that there isn't any jerkiness at the beginning. It is perfect. It was just a glitch when it opened the file. And there we go. The file restarted. So yeah, that looks really nice. 30 frames per second should make a really good rough draft quality animation. Okay, so now we went through all the work of putting the materials into these parts so we can get the real texture of the part. That was important to us, and it really looks cool when you have a photorealistic rendering. So we're going to do that. So we're going to go up here, Solidworks add-in, make sure you have this Photo View 360 chosen, and if you want you can see the render, you could just render a picture too right now, just to have one really nice looking image. We could do that real quick. Let's render with motion blur. I think we'll want that. Okay, so there's our render region. Not quite capturing what I wanted to. It's kind of missing some of it. There we go. That looks a little bit better. Alright. So we can do that final rendering. Alright. Let's... Oh, there we go. Now it's off your screen. I'll move it onto this screen if I can. And we're going through doing that photorealistic rendering. Looks like my render region still wasn't very good. Maybe that was the first version. This might be the second one. Oh, this is the preview. Okay, so anyway, we know how to render images now. So, let's render our video, and let's render it in photorealistic style. Okay, so it looks like my render region, it's going to be a little bit off, but that's okay. Alright, I'm going to make it 1920 by 1080 again, 30 frames per second. I'm going to make an MP4, and I'm going to call this one test 2. And now the key thing here is we're going to change the renderer from Solidworks screen to Photo View 360. And yeah, let's add this motion blur in here. I'm not sure if it would get that or not. I don't think it would, unless we add it. Okay, so I'm going to save this, and we're just going to watch the beginning of it here. It's going to take a little bit of time to load this, but it's going to give us an idea of roughly how long this should take. So it looks like it's going to render 151 frames. So 30 frames per second, that's about 5 seconds. That's what we requested. Okay, so it looks like it took around, I don't know, 25, 30 seconds to render one frame. Let's let it get to frame number 2, because maybe there was a little bit of stuff it had to do at the beginning. And that first frame maybe took a little bit of extra time. Okay, so second frame took about 20 seconds. So a little bit of rough math, and it seems like 20 seconds times 150 frames divided by 60 should take around 50 minutes. I have a feeling it'll speed up a little bit as we go. It'll probably end up taking around half an hour, I would guess. So half an hour. We're not going to sit here for the whole video for that, so I'll pause the video and we'll come back and look at that video when it's done. Okay, we're back, and that ended up taking about 45 minutes on my computer, and I'll show you the final product. And before we go to the video, we'll just have to note that apparently I wasn't paying attention, and my purple region for the photo rendering was not exactly perfectly centered around the Ornithopter. So you'll see that my animation is probably not the best, but I think you'll get the idea for the increase in quality. So here is the photorealistic rendering, and you can see the texture of the aluminum, and we're up pretty close, so you can see a lot of detail in there. You can see the detail of the balsa wood wings. These are aluminum gears. I can't remember if that was aluminum or steel there, but you can see a lot of that detail and a lot of that surface roughness of the material itself, which is pretty neat. And for a lot of assemblies, it looks really, really neat when you do that. Just for comparison, let's go back to that first rough draft quality. There's the rough draft quality, which is really not that bad. It's actually pretty good too. But in certain scenarios, you may want to have that photorealistic quality. So that is our demo for the day. Oh, by the way, there's one other thing you can do. You can change the view of the camera throughout the animation, and you can change how it is lit. So you can change where the lights are coming from, the shade of the lights, the brightness, intensity of the lights. You can change all that stuff. So I'll leave that for you to play with and have some fun with that. But have fun with this. It's a really fun, interesting topic, and work on the homework assignment, I guess.